You're welcome to another session of the Pilot Ground Briefs. My name is Habib Wale Hussein, and in this session, we're going to be going over the calculation of your takeoff data card. This is a supplement to the performance and limitations section. So, just for those watching on YouTube, if you're not familiar with the context of the Pilot Ground Briefs, please make sure you check the link in the description. So today's supplement is basically we'll be reviewing scenario 2, where we actually have to calculate uh, takeoff performance of your airplane. So in order to do that, we'll take a look at the full scenario here just for context. So it says, assuming in scenario 1 above, your departure airport is KISM and your destination airport is XO6, which is a software landing strip. Present a performance takeoff data card that reflects how much runway length will be required for takeoff and landing. So what I usually do is just as in scenario 1, where we use a data card. We also use a data card to calculate our takeoff and landing. And it gives us this table, sort of table, and it also gives us a spot to do our aircraft performance data. So the purpose of today's tutorial really is to just show you guys how to actually, fill out this data card, which will help you find out the performance parameters for your aircraft. So we're going to, start from the top. And just in case, if you're studying by yourself or if you're with us here at Aero Global Aviation Academy, if you're a new student, if you don't know where to find a data card like this, you can come over here to our website at aeroglobalaviation.com. You can go to the About Us page and go to the resources. And in the general resources, you should be able to download the weighting balance and performance sheet here. It has the details. It has this sheet right here where you can do your calculation. So the goal is to get a sheet like this and just fill out your name, your instructor's name, and your date, or if it's just you flying, just your name. And then I'll start here by filling out the N number for my aircraft. Here is 978 for Papa. Put that there. And then the 80s code. So I usually don't use this whenever, I'm, flying. So I typically try to fill this out usually within 1 hour to my flight time. So this, I just usually leave this blank, but for my arrival airport, maybe if I'm flying, if I get the 80s, I could put the 80s code here and then put, the rest of my details here. But, when I'm at the airport planning for my flight, usually typically within an hour for takeoff, I just start with the wind information. So for the purpose of this tutorial, I'm going to come back here to my ForeFlight app and I'll take a look at the airport here in Kissimmee, which is my airport that I'm taking off from. It's KISN. So I have that there. And what I want to do is come here to the weather and take a look at what the METAR report gives me with regards to the weather information. So right now it says the wind is variable at 4 knots. So I'm not really going to be, the tutorial is not going to be productive if I have to use wind variable. So just for the purpose of this tutorial, I'll make up like a wind direction just to help us properly fill this out. So I'll assume my wind is coming from, let's say, 330 at 12 knots. So this is my wind direction, 330 degrees. I'll just put a DEG here. 330 degrees at 12 knots. So my visibility, can come here and take a look at what it says with regards to the visibility. It says the visibility is 10 statute miles here, so I'll use 10 statute miles. ceiling here. So the ceiling, you want to look at your meter as well, get a good idea of where the ceiling is. So here it says SCT030, so that's scattered at 3,000 feet. And here it says BKN, which is broken at 035. So a ceiling is considered a cloud layer that is broken or overcast. So I'm going to be using broken at 3,500 as my ceiling. So I'll come back here, put broken at 3,500. And then the next thing will be my temperature and dew point. So in order to get my temperature and dew point, come back here. It says the temperature. It's right here. It's 32/24. So the temperature is the first and the dew point is the second. Just for context on FAA, you can come down here and see it as well. 32 degrees temperature, 24 degrees dew point. That's 32/24. And then the next one will be my altimeter setting, which is one of the important things here. Also going to look at shortly. And get my altimeter. It says the altimeter is A3010. So just remember this right here. The altimeter is very important. So put A3010, or I can just put 30.10. Just remember whatever you have there, it's your altimeter setting. And I'll come back here. Look at this. The next thing here is the pressure altitude, right? So the pressure altitude, if you've gone through the pilot ground briefs or just in general, if you're aware of the pressure altitude, there's a formula we can use to calculate the pressure altitude, especially after you get all these parameters here. So I'll come here to the course and let's see if we can find a page where we have the pressure altitude. Yeah, so I do have it here. So the pressure altitude is the height above the standard datum plane. That is the altitude indicator when altimeter setting is set to 29.92. So this is the standard, right? But we can calculate, because not every day is going to be, well, nature is not like standard. The whole standard thing is just theoretical, right? So every day is different. So what we're going to do is use our current altimeter setting, put that in this formula, and use the elevation for our airport to get the actual pressure altitude for that specific airport, for that, for those parameters. So what I typically do is I just grab my calculator. So I know just from looking at this sheet here, my altimeter setting is 30.10. So always remember to put that point if you have just four numbers. So this is to use 29.92. So what I usually do first is I just put everything in the bracket first, and then I multiply that by 1,000, and then I add the field elevation. So take 29.92, subtract that from 30.10, we get minus 0.18. So multiply that by 1,000, it gives me minus 180, and then I want to add the elevation. So to find out the elevation, I need to come back here to my FAA, figure out what the elevation for my airport is. So usually for flight, it tells you the elevation of the airport here is 82 feet for this specific airport. So I'm just going to add 82 feet to that, which gives me minus 98. So I basically just added that, and then I get minus 98 for my pressure altitude. So minus 98 is pretty much, below sea level at this point. So you see why I said so. But the next thing we'll move on is to calculate the density altitude. So we have a formula for that as well. So the density altitude, you basically just want to take the current temperature, subtract that from 15 degrees Celsius, which is the standard temperature. You multiply that by 120 and add your pressure altitude. So the pressure altitude we got from the previous page, because our density altitude is pressure altitude corrected for non-standard temperature. But it's important for us to remember, just put this note here, that this formulas that we can use to calculate the density altitude is a very good estimate of the density altitude. The equation is not always perfect, right? So just use this basically just to estimate. So I'll come back here and take a look at what my current temperature is. About 32 degrees, right? So formula says to use current temperature 32 degrees, subtract standard temperature, which is 15, gives me 17. I multiply that by 120 right there, get 2040. Then I add my pressure altitude, but because my pressure altitude is negative here, I'm basically going to be subtracting minus 98. Right? So that gives me 1942. So this is very important because this number right here, the density altitude being 1942, basically tells you at that airport, KISM, with this weather conditions right here, the aircraft on the ground at this airport is basically going to be performing as if it is at 1942 feet of altitude. So if you understand, um, how the DA is, basically the higher the density altitude, the performance of the aircraft decreases, right? So that's the idea. So the active runway, so we'll assume, just coming from 330, they'll most likely be using runway 33. So I assume they're using runway 33. If you come down here at the airport, just for context, take a look at the airport runways here. So this is runway 33 here. The one is coming from 330, we'll be using runway 33. So that's that. And then the NOTAMs, if you have any NOTAMs, usually just come back to Preflight to review any NOTAMs, to look at, anything that might affect your flight. You don't see anything here or anything new here. So if there is, maybe a NOTAM could be the PAPI lights are out for the runway 33 or something. You could just put the NOTAMs here, but I'll just leave that blank for now. So I usually just fill this out usually within the hour before I fly, because the information is the most current information you get from the METAR or the current ATIS. And then for the arrival, we're not going to be filling this out for this tutorial here, but just to give you a very good idea of how to use these numbers in your calculations for your takeoff and landing calculations, I'll I'll fill this out, right? So the next thing we'll do will be to determine the aircraft performance data. And in order to do that, you need to get access to your POH and go to, for the Cessna 172 we're using in this scenario. This is we're using basically a Cessna 172. So we'll grab the POH for Cessna 172 here. And what we want to do is go to the performance section where it has most of the performance charts. So over here, as you can see, it gives me a chart. This is at 2,200 pounds. But I typically like to use the chart that has the highest weight. This is at 2,400 pounds. And this is 2,550 pounds. So I try to use the chart with the highest weight just because the numbers are more conservative. So even if I'm lighter, the numbers are going to be a lot lesser. So it gives me a lot more room for error. So that's the idea with that. So to read the charts is very important to, make sure you read the conditions on which they use to actually publish the charts and read the notes as well. So for the purpose of um, this tutorial, we're going to be taking a look at how to calculate the takeoff distance for the normal takeoff. So coming back to the POH here, it gives you the pressure altitude and it gives you your ground roll and total to clear 50-foot obstacle. So these two numbers are what it gives you for different temperature ranges. So it's important to know what your temperature is, and it's important to know what your pressure altitude is. So our pressure altitude was minus 98, so that we can pretty much consider to be sea level, or it's below sea level, so we can just use this line, this first line. And then the next thing we want to do is determine our temperature. Our temperature is 32 degrees, so we can pretty much use the 30 degrees column right here, these two columns. So basically, using the number we get for ground roll, we'll put that in our normal takeoff, and for our over 50-foot obstacle, we'll use whatever number we determine from this point. But it's important to remember to read this note here. Please pay attention. I need to emphasize this. The notes are very important. Just make sure you read the notes, right? For example, here it says the short field technique as specified in section 4. So you can go to section 4 of the POH and read what section 4 is all about. And here it also says prior to takeoff from fields above 3,000 feet elevation, the mixture should be lean to give maximum RPM in a full throttle static run up. So, if you're in places that have high elevation, like in the Midwest America, places like Colorado, California, this is important to pay attention to things like this. And, anywhere else in the world that has a high elevation, right? In Florida here, we have like flat land, so we typically, don't worry about this. But this right here says to decrease distances by 10% for each 9 knots of headwind. And for operations with tailwinds up to 10 knots, increase the distances by 10% for each 2 knots. So this is basically, it just has to do with your wind conditions, right? And also the last one says for operation on a dry grass runway, increase distances by 15% of the ground roll figure. So if we come to the scenario here, I want you to pay attention to this because it seems like it gives us an option for grass or soft field. So soft field could be, dirt, grass, or so probably want to pay attention to that and apply some of those notes. But if we come here also, we see we have almost 12 knots of wind. So POH tells us to apply, you need to apply 10%, depending on if the wind is more or less, right? So we have to pay attention to that as well. But I'll come down here and start with the takeoff distance first. So in order to calculate that, we determined our temperature and pressure altitude, right? So what we'll do is come back here to the chart. We have the sea level and we're using 30 degrees, right? So our figure is 1070. But if you notice, it says to decrease the distances by 10% for each 9 knot of headwind. So how do we know if we have up to 9 knots of headwind? So we do need to do a wind calculation, right? So here it tells us about our headwind and crosswind component. So we can determine how much headwind component we have here before we actually calculate this number. So we can apply the notes to this number. So please pay careful attention to this. So in order to determine the headwind and crosswind component, we can come to the wind component chart. So this is the crosswind component chart here for Cessna 172. So in order to use this, you need to know that the way this table or this graph is charted is it gives you a wind component in knots, or it gives you your tailwind, usually below 0 knots, and also it gives you a headwind component above 0 knots. And then you also have the crosswind component on the x-axis. So if you come back here to our takeoff data card, so we can see our wind is 330 at 12 knots, and we're using runway 33, right? So for the purpose of this tutorial, as you can see, if we come back to the chart, in order to use this chart, you need to know the angle between the wind direction and the runway. So the runway is heading 330, and the wind direction in this current example I have now is 330. So the angle between them is 0 degrees, right? So in that case, we're basically just on this zero line right here, just like that. So it's not really helping us to understand how to get like a crosswind component. So for the sake of this example, I'll change our wind component. I'll probably say our wind is at 360, just to give us something more interesting to work with. So let's assume the wind is coming from 360 at 12 knots, right? Perfect. So we come back here and then determine the angle between 360 degrees and runway 33, which is 330 degrees. So the difference between that is 30 degrees, right? So what you want to do is find, see where we have 10 degrees, 20 degrees, 30 degrees, 40, all the way down here to 100 and almost 160, 180 degrees down here. We want to use these lines as our first reference. So we want to pick one, which is the angle between the wind direction and the runway. So in this case, it's 30 degrees. So we want to stick with this line. And then the next thing we need is the wind velocity. We need to know the wind velocity. So the wind velocity is usually with these semicircles here down on the chart. If you notice, each one has a speed. So like 5 knots, 10 knots, 15 knots, 20 knots, 25, all the way up to 35 for the last one over here. So after we have our line here, we still want to stick with this line, but we want to determine the wind velocity. And if we come back here, our wind velocity is 12 knots, the wind speed. So we can come back here and determine where 12 knots is on these semicircles here. So it looks like 12 knots is going to be somewhere here. And just notice I'm actually staying on the 30-degree line, but I'm tracking where the 10 knots of wind is, right? So it's going to be somewhere there, right there. So that is 12 knots right there on the 30-degree angle between the wind direction and the wind and the runway. So what I want to do is draw a line from that spot right there. So that will tell me how much headwind I have. So right now it looks like I have about 10 knot headwind. And then I can draw this down here to determine how much crosswind I have. So a 5 knot crosswind. So I'll come back here and say I have 10 knot headwind. And 5 knots crosswind. So that's how you determine your wind components. So once I have my wind component, I can come back and continue my takeoff distance calculation. So coming back here to the POH, go back to my takeoff distance. And don't mind the fact that it says short field takeoff distance, because you can imagine if you're taking off from a short field, for you to be able to take off on a short field, if you take off on anything that is longer, your numbers are a lot more conservative. You should be able to take off on a longer runway. So that's the idea behind them naming this a short field takeoff distance. So we come back here, and remember we're using the sea level here for our pressure altitude, and we're using 30 degrees, which is the closest to 32 degrees, right? Let's say, for example, if it was 35 degrees, we'll probably have to interpolate between these two numbers, because 35 is in the middle of both 30 and 40 degrees. So that's the idea. So we'll come back here and take 1070 as a ground roll figure, but in the notes it says the decreased distance is 10% for each 9 knots of headwind, and we have 10 knots of headwind. For the other notes, we're not really worried about tailwinds because we ended up having a headwind. So what I'll do is take my 10 knots of headwind, divide that by 9 knots, and I'm going to multiply that by my total distance here of 1070 to get how much distance I need to reduce that by. So if you're not sure of how to do these calculations, I'll just show you somewhere here where it actually gives you a full sample problem on how to apply those notes. So if you do have like the POH for Cessna, so you can come here, this formula shows you how to calculate that percentage of a decrease. So in our example, we had 10 knots headwind, and it says, it decreases out for every 9 knots. So what we can do is take our 10 knots, divide that by 9 knots, and multiply that by 10, which is our 10%. So it basically gives us 11.11%. So we're basically going to decrease our distance here to 1070. We're basically going to be decreasing this by 11%. So take that 1070, multiply that by 0.11, and it gives us 117.7. So we take that and subtract that from 1070, and we get our actual ground roll of 952.3. So the best way, you can really learn from this is if you also use your calculator to follow along. It will give you a good understanding of, how these numbers work. Always there's a saying that says, you only learn by practicing, right? So you can follow along. And then, so basically just decrease that by 11%. And we can do the same thing for our distance over a 50-foot obstacle. So we just come back to the POH, and for the same 30 degrees, just look at that distance and decrease that by 11%. So we take 1810, multiply that by 11%. It gives us 199.1. So we'll subtract that from 1810, which gives us 1610.9. So that's how you get your takeoff distance, right? Just make sure you apply the notes, right? So I'll just put a note here to let you know it's going to be an 11% decrease. If you do apply the notes. So the next thing will be to determine the landing distance, right? So obviously for you to calculate the landing distance, you also need the weather for your destination. So I'll fill out the weather for the destination here. We'll assume in this situation. So I'll put in here, it says our destination is going to be X06. So I'll come here to my flight plan on FAA. I'll put X06 and then KISM. This is my airport here. Then I just go and see what the METAR says so I can get my approximate values. Check the weather. So it gives us the weather for the airport here. It says it's advisory only. So I'm basically just going to take this with a grain of salt, but I should still be able to use it to run some numbers. So it says my wind is 080 at 5 knots. So I'll use that 080 5 knots. And the visibility is currently, so it looks like it's not giving me any visibility at this point in time. I'll just assume my visibility is 10 knots. And again, I'm just doing this for this tutorial. Obviously, when you're doing this for actual flight, you need to make sure you get the most accurate information. And then the ceiling, it doesn't give any ceiling here. So again, I'll make something up just to make sure we have something. I'll assume it is overcast 4,000, for example. And then for the temperature, says 33/26 for the temperature and dew point. So I'll do 33/26. And then the altimeter is 3005. So remember just to put a dot in the middle of that number. So 30.05. And then your pressure altitude. The pressure altitude calculations. And come back here to the formula. Just use 29.92. Subtract that from 30.05. Multiply that by 1,000. And we add the field elevation. So I need to find out what the field elevation is here for the destination. 63. So I'll add that. 63. I get minus 67. So that is my pressure altitude right there. So it looks like that's at sea level 2, or even slightly below sea level. And then the next thing will be my density altitude. And then for that, I can use my current temperature of 33, subtract that from the standard, multiply that by 120, and I will add my pressure altitude, which is minus 67. So I get 2093. So it basically means my aircraft, coming into land, be performing as if it is flying at 2,000 feet, or almost 2,100 feet. So at this airport, with these winds, say 080. Just take a look at this one more time. 5 knots. So we'll come here, take a look at the airport, and see the winds are coming from 080. Could basically use this runway, but the scenario is telling us to use a soft filled runway, right? So the soft filled runway is this colored in green right here, right? So for the purpose of this scenario, let's assume we choose to land on runway 32, right? It tells you runway 32 is about 315 degrees right here. So almost 320 degrees. So we'll just assume it's, the active runway is runway 32. So 320 degrees heading. So while we don't have a space here to calculate the headwind and crosswind component for that, we could just go through it one more time, right? We do need to determine the angle between the wind direction and the runway. So in this example, the wind direction is 080 and the runway heading is 320, right? So basically have 320, subtract that from 080, we get 240 degrees. So that is so huge in terms of the differences, and it doesn't even show up on the scale here. But because the wind speed is very low, it's less than 5, I'm not going to worry too much about, calculating that portion, because over here in the POH, as we can read on the note, it only says if the wind is about 9 knots, right? So wind is not up to 9 knots, so we really don't need to decrease any distances for this example. But we'll be assuming it's going to be on a dry grass runway, so it says to increase distances by 15% in this case. So what we're going to do here is come out here and we'll fill out the available runway length here for XO6. I'll put the available runway length here for the short field runway. It says the length here, it tells you here is 2,400 feet. So put that in here. And then you can do the same thing for KISM. That way we stay consistent with the details. You can go back to KISM and figure out, I should have done this earlier as well. Let's just show you, just to make sure the distances were calculated earlier actually will be enough for takeoff, right? So it says it's 6,001. So come down here, I'll put this here, 6001. So just coming back here on the initial calculation, as you can see, we have way more than enough runway for a normal takeoff and for takeoff over 54 obstacle, which will take about 1,610 feet of runway space. We have a 6,000-foot runway, so it's more than enough room. But for our arrival at this airport, let's see if we're going to have enough room to actually land, right? So we'll come back here and calculate the normal landing distance. So in order to do that, we need to use a separate chart. So we need to use the chart that actually says landing distance. So it looks like this here gives us the landing distance at the maximum takeoff weight of the aircraft. So we can use this, and if we come down here, we already determined our partial altitude is going to be at sea level. So we'll be using this first line. The temperature is 33 degrees, so we can use this 30-degree portion right here. So coming down here, it says the ground rule is going to be 605 feet for landing. So if we come down here, remember our notes, just because this is going to be considered a dry grass runway, soft field, we need to increase the distances by 45% of the ground rule figure. So how do we do that? Basically similar to the earlier calculation we made. We have to take that number, this number right here, we'll get 45% of this number, and add that 45% to this number to give us our actual number. So 45% of 605 feet, let's see what that would be. So it would be 272.25, and we add that to 605. So we basically get 877.25. So that's that for the normal landing distance. Then the next thing to do will be to determine the total to clear a 50-foot obstacle, right? So this would be 1380, right? So in order to fully calculate this, we can also figure out, if we, just in case if we have to clear a 50-foot obstacle, we'll have to calculate 45% of that, which will be 0.45, multiply that by 1380, get 621. Add that to 1380, we get 2001 feet. So this number is basically 2001 feet. After we add 5% of our ground rule. So I'll just put that note there for you as well, just so you know. So that's the scenario right there done to give you a good context of how to fill out your takeoff and landing data. So the last thing I'll like to touch upon here is how to go about, filling out your V speeds. So your V speeds are, very important for you to familiarize yourself with this, because as a pilot, you're flying the aircraft, you need to be able to tell what the wind speeds are and things like that. So if you come down here, we'll start with the VSO. So in order to know what the VSO is, and this is for the specific aircraft we'll be flying, we'll come to the POH, and there's a specific page that gives you information on all the V speeds, right? So here's the limitations page, but you also do have another page that gives you an idea of like the color coded markings on your instruments, and you also have another page that explains all the terms. Let me see if I can find those here. The terms of your V speeds right here, right? So your VSO, for example, it tells you your VSO is your stalling speed or the minimum steady flight speed, which is the minimum speed at which the airplane is controllable in the landing configuration at the most forward center of gravity, right? So this is usually considered, you know, it's considered, your stalling speed in the landing configuration. And then you also have VS right here. So if you come down here, if you're not sure what these are, you can just come back to the POH here and read the terms. Like you have here your VX. It tells you here what VX is your best angle of climb speed, which is the speed that results in the greatest gain of altitude in a given horizontal distance. So you get the idea. So I'll just come down here and give you the specific speeds for this aircraft here and how I actually obtain them. So for my VSO, on this aircraft, I'll come down here to where it gives me my arc, right? So the VSO is usually considered the lower limit, which is the VSO point. So this is about 40 knots right here. So on this aircraft, VSO is going to be 40 knots. And then VS1, which is typically you can consider VS. You can consider that to be VS. We'll come out here and take a look at how to figure that out. So it says the lower limit is the maximum weight VS1 at most forward CG with flaps retracted. So the green arc, sort of like the lower limit of the green arc, is your VS1, which is 48. So I'll come down here, put 48 in here. That's my VS1. And then my VR, just from reading the POH, I don't have to go through that, but the rotation speed for this aircraft is 55 knots. And the VX, which is your best rate of climb, if you come here, doesn't give us the VX here, but on the actual checklist, it's going to be in the other section. It tells us the VX for this aircraft is 62 knots. So I'll put 62 in there. And a VY is the best rate of climb, 74. And then VA, it tells us about VA here, which is maneuvering speed. So for the maneuvering speed, it gives us the maneuvering speed with different weight configurations on the aircraft. So I typically like to go for the maximum weight, which is about 105. But obviously, depending on how your aircraft is loaded, if you do your weight and balance data, if your number is closer to 2,200 for your takeoff weight, you should know it's only going to get lesser the more fuel you burn. So your maneuvering speed is actually going to be closer to 98 than 105. So for the purpose of this tutorial, I'll just put 105 there for our VA, but just know this changes, right? This variable. And then VNO. So VNO is our maximum structural cruising speed, right? So it says this is basically the remarks it gives us is do not exceed the speed except in smooth air, and then only be cautioned, right? So I'll be using 129 here. Just pay attention, I'm using the not indicated airspeed, the KIES, because that is what we actually see indicated in our cockpit. So I'll use 129 for that. And the next thing is the VNE. So the VNE is the never exceed speed, which is, says here, do not exceed this speed in any operation. So it's 163. 163. The VG is the best glide speed. If you read through the POH, you get to figure out VG is 68 knots. And the VFE here is the maximum flap extended speed. So it gives you two options with flaps at 10 degrees and with flaps from 10 degrees to full, which in this aircraft is 30 degrees. So it's 110 and 85, right? So here I'll put 85/110. And then the approach speed, you can typically get that from the checklist in the aircraft as well. Typically recommends approaching at 65 knots. And the maximum crosswind component. So in the maximum crosswind component of this aircraft, you can get that on the POH as well. I don't want to scroll too far, but I believe the maximum wind component of this aircraft is rated at about 17 knots. So basically cannot fly in a crosswind component that's more than 17 knots. But just for safety, I like to keep it at 15 knots. So I'll just put 15 knots in here just to make sure, you know, we keep conservative numbers. So that is the idea, and that is how you fill out your performance, your takeoff and landing data card. So for everybody out there that's currently going through training, or if you're planning on becoming a pilot, I'll suggest you always take the time, usually within 1 hour of your flight, to fill out this data card for every day you're going to be flying. Get to practice and understand these numbers and how it relates with the performance of the aircraft. Because by the time you get to your check ride, you would have built a habit of, understanding what all these numbers mean. And what the FAA examiner actually wants you to know is what these numbers mean, and to be able to use it to tell how the aircraft performance is going to be. If, okay, this number improves aircraft performance, or if it decreases aircraft performance, like the density altitude, for example. A lot of, examiners like to talk about the density altitude and how it affects aircraft performance. You can study up on that and, understand the formula, know how to use it, know how to apply it, know the pressure altitude, know how to calculate it, know what it's all about, and everything else, just know how to obtain these numbers. Yeah, so what I'm going to do is I'll save this and add that also as a supplement so you can review this on your free time, and just make sure you understand, you watch the full video, you understand how we actually got these numbers. And for your check ride, just follow these procedures. If you get these numbers correctly and you watch the video, you understand, and you practice through your training every other day you fly, it will be easy for you to explain this on your check ride, and you're actually going to impress your instructor and have a successful check ride. So thank you for joining me on this one, and I'll see you guys on the next one.